Okay. Can you hear me? Boleh dengar ke suara saya?
Boleh sir.
Okay. It's like this. I understand the internet connection now is very poor. Ramai orang lagging. Jadi untuk mudahkan kerja kita dan jangan buang masa, Google Meet ini saya akan record. Okay, dan saya akan upload lepas kita habis kelas lah, saya akan upload di YouTube. Okay, jadi kalau tak dapat nak dengar dengan berapa jelas, don't worry. The Meet will be recorded for your reference, but you have to watch the Google Meet after we finish the class. Jangan tak tonton pula Kalau you didn't watch, sorry, if you do not watch the YouTube later, then you don't understand what we are going to discuss now. Is it clear? Okay, I hope it's clear lah, right? Okay, so we are going to see question.
Yes sir.
Okay, so good. Okay, we are going to see question 4 in tutorial. Please look at the tutorial question number 4. Okay, go to your my Google site or the document you have downloaded. Please look at question 4. Question 4 tutorial Soalan 4 tutorial. Okay. Dan sila rujuk kepada Jamboard link terkini yang saya bagi tu. Yang H4P2 punya Okay. Okay, for the reaction A plus B, so I'm going to discuss. I stop this one. I stop this screen. I'm going to share the Jamboard screen. Which titles H4P2 punya lah. So saya pergi ke slide number 8. Okay. This is question 4, tutor 8. Okay. Question 4, tutor 8. For the reaction A plus B produces C, A plus B produces C. If the concentration of A is triple, the rate increases by 3 times. Okay. Concentration of A is triple, then rate become 3 times. So let's say before I write this one, I write the general one. Rate equals to K A power X B power Y. Okay, this example, this is called generally lah. Generally, okay, secara keseluruhan generally. Let's say we read the question. They say if concentration of A is triple, so this is rate, the new rate. Okay, if concentration of A is triple, we don't do anything to B. B kita tak buat apa-apa, kekal. Okay, the rate increases 3 times. Okay, this is our understanding. Okay, I repeat again. Generally, that is the rate law. Generally, this is the rate law. Okay, if let's say we increase the concentration of A 3 times, the rate increases 3 times as well. Okay, that is the first thing we do. The next is second statement. In another experiment, when concentration of B is double, so there's another experiment. When concentration A, you don't do anything. Sorry. B, you double. Okay, double and 2 kali ganda lah, double. The rate increases by 8 folds, 8 kali ganda. Okay, so dia seolah-olah macam ini kalau kita nak bezakan, ini equation 1, ini equation 2, ini equation 3. Ada 3 equation lah. Got 3 equation, right? Before that, don't forget to key in attendance. Saya lupa nak ingatkan, sila key in attendance. Kejap, saya type dekat chat box. Because I scared some of you do not forget to key in attendance. continue back. So we have three equations generally, and then two different situations. So the question asks us, what is the rate law? That means we have to find what is order of both species A and B. What is the order? That means nilai X dan Y kita kena cari lah. Okay. So the working, I shall continue. I go to the next slide. So very simple. Let's say equation 2 divided by equation 1. Kita ambil ini dulu. Equation 2 divided by equation 1. Equation 2 is 3 rate equals to K 3AX BY. Okay, BY. Divide by equation 1 rate equals to K 3A, sorry, not 3A, A power X B power Y. Okay. So mathematically, what we can do is we can cancel. Rate can cancel, BY can cancel, K can cancel. Okay. And A pun boleh cancel. A boleh cancel. So what we remain now, what we have now is this side on the left hand side remain 3 equals to, on the right hand side remain 3 power X. That means X is equals to 1. Or we say first order respect to A. Boleh ke setakat ini? Ke ada soalan? Siapa yang dengar boleh tanya. Is it okay, guys? Those who want to ask question can ask. Isyang okay, Isyang?
Okay, sir. No problem.
Okay. Okay. How about others? Those yang boleh dengar lah, yang lagging tu, sorry lah. Apa saya record Google Meet ni. Don't worry. You can, okay. Ada yang okay lah. Good. Alright. So that is X. Now we find the value of Y. So what we do is, let me change. Equation 3 divided by equation 1. We do like this. Okay. Equation 3 divide. So that is 8 rate equals to K A power X. This is 2BY. Then divide. This is rate, equation 1. This is K. Sorry, no equal sign, sorry. This is A also. Power X. This will be B. So B power Y. Okay. So what we do here is, we can cancel similar to just now. Rate boleh cancel. K boleh cancel. A boleh cancel. B pun boleh cancel. So apa yang kita dapat di sini sekarang adalah 8 equals to 2 power Y. Okay, 2 power Y. Right? So Y is equals to, what will be Y? 3. Am I right? Third order
3.
respect to B. Okay, kita dapat third order respect to B. So we haven't finished. Our answer not yet finished. We go to the last part. That is, we make a conclusion. Thus, the rate law equals to K A B power 3. This is the rate law. Dapat the rate law ni. Dapat, Okay, good. All right. So we will proceed with the next question. The next question is, I underline first. Or I use the pen, different color pen. The next question we are going to see is question 7 to 8. Okay. I want you to read the question first. I give you maybe 2-3 minutes to read the question first. Question 7 to 8. Baca dulu soalan dia. This is for your information. This is applying integrated rate. Integrated rate law. Okay, formula. This is applying integrated rate law formula. Question 7 is about applying the integrated rate formula. Okay. All right. The decomposition of dinitrogen pentaoxide with the rate constant of 5.1 times 10 to power negative 4 per second at 45 degrees C is given below. Okay, 2N2O5 produces 4NO2 plus O2. Right, so that's the equation. Calculate the half-life for the decomposition. Calculate the concentration of N2O5 after 3.2 minutes if the initial concentration is 0.25 molar, and see if the initial concentration of N2O5 is 0.35 molar. Calculate the time needed for the concentration to be reduced to 0.08 molar and by 62%. Okay, right. We see the information in the question. Information given in the question, they give us the rate constant, or they give the K value 5.1 times 10 to power negative 4 per second. Okay. This is very important information, because if we want to apply the integrated rate law formula, we have three formulas. Zero order, first order, and second order. We got three formulas that we can apply. So for this question, among those three, which one we are going to use depends on the unit of rate constant. Depends on the unit of rate constant. Perhatikan unit dia. Unit is per second. Per second, which order? Zero order, first order, second order. Saya dah terangkan dalam video. Any suggestion? First order, good. So second is for first order. From the unit, yes, first order of reaction, correct. Okay, so at this moment, you have to remember the integrated rate law and half-life for the first order. Okay,
first order.
Yes, good. Integrated rate law will be ln, in this case, we apply the species, N2O5 naught divided by N2O5 equals to KT. Okay, sorry. This is the formula. I bracket. This is the formula. It's called integrated rate law or integrated rate equation. And we also have another formula called half-life. Sorry. Half-life. Half-life for the first order is ln 2 divided by K. This is the another formula. Okay. So, perhatikan soalan ini sangat penting. Daripada info ini, kita kena kenal pasti apa formula kita nak guna. Cara kita kenal pasti adalah melalui unit pemalar kadar tindak balas or rate constant, which is per second. And from there, we determine it's a first order. So far, good? Okay, can understand?
Okay, sir.
Okay, all right. I hope you can understand. All right, now we go to the question. Next slide. Slide seterusnya, slide number 11. Next question. Okay, the first part, excuse me. The first part, A They want the half-life. So half-life equals to ln 2 divided by K. Ln 2, I think 0.693, if I'm not mistaken. K we got from the question, 5.1 times 10 to power negative 4 per second. So kita kira half-life. We calculate the half-life, ln 2 divided by 5.1 exponent negative 4. I got 1359 second. Dapat ke atau dapat jawapan lain? Excuse me.
Same, sir.
Same Isiang? Okay, same. Okay, saya harap semua pun dapat sama lah. Okay. Alright, B. Now we go to B. Calculate the concentration of N2O5. So they want to know the concentration of N2O5 after 3.2 minutes. Okay. After 3.2 minutes, if the initial, if the initial concentration is 0.25 molar. Okay. If the initial concentration N2O5 not itu adalah 0.25 molar lah. So what is the concentration after 3.2 minutes? Okay. Then we have to use the integrated rate law for first order. Ln N2O5 not divided by N2O5 KT. Okay. An important thing we have to take note here, pelajar kena perhatikan adalah our K unit is second. Per second lah, second. But the time given here is in minute. Okay. Meaning, if I want to use the integrated rate law formula, kalau saya nak gunakan formula ini, unit K dan T mesti sama. Supaya kita boleh cancel the unit lah. Unit K and T must be same. So that means our 3.2 minute, we have to change to second. 3.2 minute have to change to second. I hope you know how to change. I got 192 second. 192 second. Betul ke?
Betul.
Okay. And ln, gantikan semua nilai. 0.25 is... Betul Okay, N2O5 not. 0.25. N2O5 ni yang kita nak kira. K 5.1 times 10 to power negative 4 per second, ataupun boleh tulis macam ni untuk mudahkan kerja cancellation. You letak per second macam ini. Okay. And then multiply with T. T is 192 second. So apa yang kita boleh cancel? Kita boleh cancel second. Okay, boleh cancel second. Maka kita boleh kira N2O5 final concentration berapa. Boleh kira. Okay, this is mathematics lah. Anyway, sama-sama kita kira. Saya dapat 0. Kita ambil 3 significant figure. Saya dapat 0.227 molar. Betul ke? 2-3 pun boleh lah sebenarnya. Sebab molar dia dalam 2 significant figure. Cuba kira berapa dapat. Betul ke jawapan saya?
Sama, sir.
Sama ni 227 Okay. How about others? Satu lagi jawapan betul ke yang saya kira ni? Just to cross check. Betul, okay. Alright, good. So it's 0.227 lah. Right. Then itu adalah, that is part B. Now we go to part C. Okay. Okay, part C is C part 1. C part 1. They ask if the initial concentration, so N2O5 naught is 0.35 molar. Calculate the time needed. They want to know the time needed for the concentration to be reduced to. That means your final concentration will be 0.08 molar. Okay. So they want to know the time. So this is also application of the formula. Ln N2O5 naught divided by N2O5 KT. So ln 0.35 divided by 0.08, 5.1 times 10 to power negative 4 T. Therefore, T equals to, also you can get in second. Okay. This one also simple calculation. I get 2893 if in minute or 48.3 minute or 0.80 hours. So ada tiga jawapan lah. You can give in second, you can give in minute, you can give in hours. 804 hours. Okay. Sama ke jawapan anda dengan jawapan saya? Sifat 1.
Yes, sir.
Sama, okay. So the option I give you 3 options because sometimes the question wants the answer in, they will mention whether they want in second or minute, or sometimes they can ask in hours, especially when it comes to half-life. Okay, so make sure you know the conversion. Although it looks very simple, but make sure you know the conversion lah. The interconversion between second, minute, and hours.
Sama, sir.
Sama, okay, bagus, right. Okay, then we go to the C part 2, the last part. Okay, C part 2. Okay, C part 2 is we read back the same thing. The initial concentration N2O5 naught is 0.35 molar. They want to know the time taken, right? Time needed to the concentration to be reduced by 62%. This one a bit different. Okay, let's say there is a timeline. This is my N2O5 naught, and this is my N2O5. Okay. So I start in terms of percentage because the info given is by 62%. Okay, that's the info given. So in terms of percentage, initially will be 100%, and when they reduce by 62%, that means balance is 38%. Ini cara kita nak baca. I repeat one more time. Because they said reduced by 62% in terms of percentage, and maximum percentage initially will be 100, because this is a reactant, definitely it reduces with time. So the initial should be 100%, and then 100% it reduces by 62% by berkurang sebanyak 62%. If we decompose 62%, that means this is the balance after the decomposition, which is 38%. And for this process, the question asks us to find the time needed or time required for the decomposition by 62%. Okay, so similar formula, ln N2O5 naught N2O5 KT ln 100. This is 38. Then K is 5.1 times 10 to power negative 4. Find the T. Okay. 0.1897 second. Is it correct?
Correct, sir.
Correct. How about others? Anyone get different answer?
Same, sir.
Same answer. Okay, good. So this recording, I stop first.